Every time you scroll, call, or even blink at your screen, there's something working silently behind the glass. Something so small, yet powerful enough to drive entire civilizations of technology. That tiny thing is a chip, or more precisely, a microchip. It's the brain inside your smartphone, the heart of your laptop, and the soul of artificial intelligence. But behind this miracle of modern science lies an invisible process: chip designing, the art and engineering of creating these microscopic masterpieces. Before we talk about chip designing, let's understand the chip itself. A chip, or integrated circuit, is a piece of silicon containing millions or even billions of transistors, tiny switches that turn electricity on and off. Together, these transistors form logic gates, circuits, and processors that execute every digital operation you can imagine. Think of a chip as a city built for electrons. The roads are wires, the buildings are transistors, and the traffic lights are logic gates controlling the flow of data. Chip designing is the process of planning and constructing this city with such precision that even a single misplaced road could crash the entire system. Designing a chip doesn't happen overnight. It's a long, multi-stage journey involving creativity, physics, and extreme attention to detail. It begins with architectural design, defining what the chip should do. Is it for gaming, AI, mobile performance? Each purpose demands a different architecture. Next comes logic design, where engineers use hardware description languages like Verilog or VHDL to describe how the chip will behave, step by step, signal by signal. Then we move to circuit design, where those logical blueprints are transformed into real electronic circuits. Here, timing, voltage, and power management are optimized for efficiency. After that comes physical design, turning logic into geometry. Layers are arranged, metal connections are drawn, and the layout is prepared for manufacturing, often with the help of software like Cadence or Synopsys. This entire process can take months or even years. Once the design is perfected, it's time for the most expensive step: fabrication. At this stage, the digital design is handed over to semiconductor foundries like TSMC, Samsung, or Intel, where chips are built on wafers of pure silicon. Using nanometer-scale lithography, circuits are etched layer by layer, forming structures thousands of times smaller than a strand of hair. Imagine printing an entire skyscraper on the head of a pin. That's the level of precision we're dealing with. A single fabrication plant can cost billions of dollars, and even a dust particle can destroy a chip worth thousands. Before a chip ever reaches your phone or computer, it undergoes rigorous testing. Each stage, from simulation to post-layout analysis, ensures that the chip works exactly as intended. No overheating, no glitches, no timing errors. This process, known as design verification, is one of the toughest challenges in chip engineering. Because when a chip fails, it doesn't just break a device, it can break a company's reputation. The world's biggest tech race today isn't about screens or apps, it's about chips. Companies like Apple, AMD, and Qualcomm are in a continuous battle not just for speed, but for efficiency. And then comes NVIDIA, a company that completely reshaped how chips are used. Its GPUs, originally built for gaming, became the backbone of the AI revolution. If you haven't watched our previous video, The Rise of NVIDIA, check it out in the I button or the description below. It'll show you how one company turned chip design into global dominance. Smaller transistors mean faster computation, but more complex designs. At 3 nanometers or below, even quantum effects start to appear. Electrons begin to leak, creating unpredictable behavior. That's why chip designing has become an art of balance between performance, power, and precision. Every nanometer saved, every watt reduced, means billions in global impact. From AI algorithms to space exploration, from electric vehicles to smart homes, everything relies on chips. And at the center of that ecosystem are chip designers, unsung heroes who translate abstract ideas into physical intelligence. They are the architects of computation, the painters of electrons, the engineers of possibility. Without them, your smartphone wouldn't wake up, your AI model wouldn't train, and your digital world simply wouldn't exist. The next decade will redefine what chips can do. We're entering the era of AI-designed chips, neuromorphic processors, and quantum-inspired architectures, chips that don't just compute but learn. As the digital universe expands, the art of chip designing will remain at its heart, silent, invisible, and infinitely powerful. And if you want to see how companies like NVIDIA are shaping this very future, make sure to watch my previous video, The Rise of NVIDIA. Links right in the description. Because understanding the design is one thing, but understanding who mastered it, that's a story you don't want